Hey everybody. In this unit, we've been doing a lot of work with linear equations, right? Finding the slopes, manipulating them, writing them in different forms, finding the intercepts, graphing them. Tonight, we're going to take all of those concepts, all of those skills that we've learned, and we're going to apply them to not graphing linear equations, but graphing linear inequalities, okay? Linear inequalities are just like linear equations, except instead of an equal sign, we have a greater than, a less than, a greater than or equal to, or a less than or equal to sign in the mathematical statement. So in our first example here, I just want to know which of these points is not a solution of this inequality right here. And to do that, we just have to see which of these values, which of these points makes this statement not true. So let's start with A. If I substitute 0, 0 into this inequality here, we want to see does it make it true or not. So remember, we have x and then y for every point. So we're going to substitute 0 for x minus 3 times 0 for y is less than or equal to 6. Is this true or not? Well, we have 0 minus 3 times 0. So 3 times 0 is 0. 0 minus 0 is 0. So I end up getting 0 is less than or equal to 6. And that's true. So A cannot be the answer because we're looking for which one is not a solution. So let's try B. B, I have 6 for my x and negative 1 for my y. So I have 6 minus 3 times negative 1 is less than or equal to 6. Now, negative 3 times negative 1 is going to give me positive 3, so it's going to be 6 plus 3 is less than or equal to 6, and I get 9 is less than or equal to 6. And this is not a true statement, so this ordered pair right here is not a solution to this statement. Now, that means that C and D are both going to be solutions, right? If I put 10 in for x and 3 in for y, 10 minus 9 is 1. 1 is less than or equal to 6. The thing is, there are infinitely many solutions to this statement, right? Not just these three. There's also all kinds of different pairs of numbers that would make this true. There's also infinitely many points that would not be solutions. So when we're graphing linear inequalities on a coordinate plane, we want to make sure we show all of the points that are solutions to this and all of the points that are not solutions. So when we graph an inequality in a coordinate plane, the graph of the inequality is the set of points that represent all solutions of the inequality. That's the important part. The reason we show all of the solutions on a coordinate plane is because we don't have time to write them all out. It's actually easier to show it than it is to write them all out because we'd never be able to write them all out. The boundary line of the linear inequality divides the coordinate plane into two half planes. So when we graph our line and our inequality, half of the graph are going to be solutions and half of the graph are not going to be solutions. And that'll make a lot more sense once you see it. In order to do this, we follow 3 steps. Step 1, we graph the boundary line. Step 2, we test a point that is not on the boundary line, and we want to see whether or not that ordered pair is a solution of the inequality. And then what we want to do is we shade in the half of the graph that contains all of our solutions. Okay, so let's see a couple examples and you'll get the hang of it. All right, for example A here, we're going to graph the inequality y is greater than 4x minus 3. So normally, right, if this was y equals 4x minus 3, we would just graph that line. But here we're going to have to do a little bit more. But the way we start is we graph the boundary line. So we graph this just like if we were going to graph y equals 4x minus 3, right? So if we graph this, y equals 4x minus 3, I'm going to start at the y-intercept, which is at negative 3, and I'm going to use my slope to find a couple more points here. So I can go up 1, 2, 3, 4, and to the right 1, up 1, 2, 3, 4, and to the right 1. Now, here is where a lot of people run into trouble. We have our points, we see what direction our line is going. Now, the way our line looks is going to depend on what type of inequality we're using. Because this is greater than, we are not going to use a solid line. Think about when we were graphing inequalities on the number line, right? If it was greater than, we use an open circle because that means that it can't be equal to. Very similar thing with linear inequalities. But instead of an open circle, we are going to use a dashed line. Now the dashed line represents the fact that the points on the line are not solutions to this inequality, right? Because it doesn't say that y could be equal to 4x minus 3. It says y is greater than 4x minus 3. So these points on our line are not actually part of our solution. All of our solutions are going to be on one side or the other. So what we have to do next is we're going to pick one point on one side of the line, and we're going to see if that point is a solution. Now, one point I always like to use if I can is 0, 0, because 0 is really easy to work with, right? I know anything times 0 is going to be 0. I know anything plus 0 is going to be itself. It makes things nice and easy. So we're going to put in our x and y values from this point into our inequality. So for step 2, when I'm testing a point, I'm going to plug in my values. 0 is greater than 4 times 0 minus 3. And when I simplify both sides, I get 0 is greater than 4 times 0 is 0 minus 3 is negative 3. Now this is true. That means 0, 0 is a solution. That also means that tells us that all of these numbers on this side of the line are going to be solutions. So what we do is we shade in that side of the graph to show where all of our solutions are. If we tested any numbers over here, we would see that these are not solutions. For instance, if I tested 4, 0, 0 is greater than 16 minus 3, that would be 13. 0 is greater than 13, that would be false. All of these points here would make this statement false. So what we see from our graph is all of the points to the left of this dashed line right here, all of these points over here are solutions. None of the points on the line are solutions, and none of these points over here are solutions. All right, let's take a look at another inequality. X plus 2y is less than or equal to 0. So a few different things we want to do here. First step is to graph the boundary line, okay? So this is the equation of the line. All we did is I replaced, less than or equal to with equal to, because this is the line that we're going to graph. Now, a few different ways I could graph this. I could find my x-intercept, right? Remember the x-intercept, this is in standard form, so it's c divided by a, which is 1. So my x-intercept is 0. Oh, and that's actually going to give us 0 for our x value because 0 divided by 1 is 0. Our y-intercept, right, is c divided by b. So that's 0. We know x is always 0 at the y-intercept. So our x and our y-intercept give us the same point here, right? So we only have one point, but we can use the slope to find more points. My slope is negative a over b, so negative 1 over 2 is negative 1/2. So my slope, I go down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And we can go the other way as well. Want to get in as many points as we can. Now, because we have less than or equal to here, the type of line we're going to draw is going to be a solid line. Because x plus 2y could also be equal to 0, that means these points on the line could be solutions to the inequality. Okay, this is like having a closed circle on the number line. So we're going to draw a nice, straight, solid line right here. And put arrows on that. And now what we need to do is pick a point that we can test. So I'm going to pick a nice, easy point. It's going to, give me some easy calculations to do. So let's pick 0, 1. Right? We can pick any point we want on either side of the graph. I just want to pick a point that's going to give me easy calculations. So 0, 1. and we can plug that in to our inequality. So we have 0 plus 2 times 1 is less than or equal to 0. So we have 0 plus 2, that's 2, is less than or equal to 0. Now, this is not true. We picked a point that does not give us a true value. So what we want to do is, instead of shading in this side, right, we found out this doesn't work. That means that none of these points over here are going to work. We are going to shade in this side, because if this half doesn't work, that means this half has to. So we will shade in everything over here, and now we see where our solutions are. Our solutions are on this line. All of these points on this solid line are solutions, and all of these points below the line are also solutions. These points up here, not solutions. They will give us a false equation if we substitute it in. Okay? I know you probably have a lot of questions. That's okay. We will get all of those answered tomorrow. Go ahead and complete your notes, and I will see you guys in class. Have a good night.